In this video, we'll take a closer look at HTTP response. HTTP responses are the output of a web application. Most of the time, the responses are HTML pages, which we already know how to create. But occasionally, we may need to generate non-HTTP content. So we need to have a good understanding of HTTP response. This is a web page on CS3, and this is a request and response of the web page captured by TCP/IP monitor. We've discussed the request in the last lesson, so let's now focus on the response on the right-hand side. As we can see, just like request, HTTP response also has three parts. The first line is called a status line. And then there are a number of headers, and then the response body. We can change how we view the response body in TCP/IP monitor. By default, it shows a browser view, so it looks like the page displayed in a browser, but you can change it to byte view so that it shows the raw content of the response. As we saw, the HTTP response body typically contains a requested web page, and the status line includes a protocol and a status code. Status code 200 indicates that the request was processed successfully. You have probably seen other status codes before. For example, 404 page not found is quite common, and occasionally you'll see websites returns a 500 internal server error, and sometimes if you try to access a web page that is password protected, you'll get a 401 error, or you'll access a protected resource that you do not have the access privilege for, you'll get 403 forbidden error. And in fact, when we write response.sendRedirect in servlet code, it actually sets a status code of 302 in the response. There are in fact many status codes, not just the ones that we commonly saw. To easily recognize the general status of those codes, they are grouped into several ranges. Status codes between 100 and 200 tell the client to perform further action, and from 200 and 300 means the request is successful. In fact, there are different success status codes, not just 200. And from 300 to 400 means a resource has moved, so the client browser should send another request to a new location. And 400 to 500 means there's an error and it's caused by the client. And 500 to 600 means the error was caused by the server. One usage of status code in a Java web application is to display customized error pages when a certain error happens. For example, here, I'm trying to access a page that does not exist, and the application server will provide a default 404 error page. But notice that the application server generated error page looks quite different from other pages of the application, and it may include information you don't want your users to see. For example, the name and version number of the application server. To provide our own error page, we can specify a page and what error code it handles in the web.xml file. So here, for example, we can first create a custom error page, and let's say I'm going to call this 4.html, and I'll say the page you are looking for is not on this site. And then inside the web.xml page, we can add an error page element and point to that page we just created. So let me save. Why is taking this long to save? Okay, so it's saved. I hope my hard drive is not failing. So if we run this, so this time it has a 4 error, but the IE browser, I think, does not display the error page. It displays its own error page. So let's try a different browser. And the Edge browser or Chrome or basically any other browser will properly display the error page that we just created. So this is how we can create customized error pages in a web application. And then let's talk about headers. Lots of the response headers have their counterparts in the request headers. For example, these accept request headers tell the server what types of content the browser can receive, and these content response headers tell the browser about the content of the actual response. Most of the time, you don't have to set response headers directly. For example, when you call the method response send redirect, the method will automatically set the location header for you to tell the browser where it's supposed to be redirected. However, occasionally you may have to set a response header yourself. We'll see a couple of examples later on how to use the refresh header and the content disposition header. Just like request, Java encapsulates HTTP response in an object so we can access different parts of a response using method calls. As you can see here, lots of response methods deal with headers. Add a header of certain type, get a header, set a header, and so on and so forth. There are a few response methods that are used quite often, other than those header-related methods. We have already used set content type and send redirect before. And then we also used getWriter quite often in order to generate HTML pages. Later we'll see an example of using getOutputStream. If you remember Java I/O, remember that there are two general types of classes in Java I/O API. You have readers and writers, and then you have input streams and output streams. So we'll see reader or writer. It means it's something that you can use to either read or generate textual data. And if you see input stream or output stream, it means they are used to deal with binary data. The difference between text data and binary data is that text has an issue of language and encoding. So that's why readers and writers are designed to be aware of encoding and languages and so on. But binary data is just zeros and ones, so they are handled by input and output streams. So with that knowledge, let's look at some examples. The first example I want to show is revisiting send redirect, because this is a method that's often misused and that leads to some error that's quite common. So I have this add form from the examples of last time, and this add form has two input fields which supplies two request parameters to a servlet, and this servlet will take the two request parameters, check if they are null or empty, and right now if they are null or empty, we simply set a default value of 0. So let's change this. Instead of setting default to 0, we'll redirect it back to the page. Before we do that, actually, just let's run it first. So we'll say add form.html, and if I say 10 and 20, it will show 30, which is what we expect. If we leave one or both empty, it simply set it to 0, and it still produces something. So let's say I want to change this code so that if one or both of the parameters are empty, we want to redirect to the original, to the add form page. So the code will be something like this. We'll say if PA is null, or PB is null, or PA trim.length is 0, meaning that if we trim out all the white space characters and the remaining string's length is 0, that means it has only white space characters, nothing else. So we don't want that, and we'll do the same thing with PB. And if any of that is true, we'll do a response send redirect, and we'll redirect it to add form.html. So, and here we'll say integer plus int PA plus integer plus int PB. And let's change this to PA and PB. Okay. So let's see how this thing looks like. We'll go back, and again we'll give it two parameters, and so it works fine. And if we remove one of them, now we get a number format exception, which says we are trying to convert an empty string into an integer, so the line of error is 36, which is here. Now if you look at this code, it says we are trying to convert an empty string into an integer, that's why we got the exception. However, if you look at the code, you'll say, didn't we already check for empty string here? Then shouldn't the client be redirected to the add form instead of continuing to this line? And this is why I want to show this example. It's a common misconception about send redirect, thinking that once you call send redirect, the execution of the method will end and then the client has been redirected to somewhere else. That is actually not true. Send redirect does not terminate the execution of either do get or do post. If you remember your Java knowledge, nothing ends the execution of a method unless you say return. So if you do not put a return statement here, it will continue to the next line, even though you think the client has been redirected. So it's very important if you use send redirect somewhere in the middle of your code to add a return statement. This ensures that the execution of the method will end and the response will be sent back to the client. Otherwise, it will continue. So with that change, let's try this again. So we go back, and this time we click this, and note that this time we are not getting the error. In fact, the user has been sent back to this page. That's why the value for A is gone, because it's getting back to this page again. So it works properly, and if we give it two values, it will show the correct sum. It's a simple example, but a very common mistake. Remember, send redirect does not end the execution. You have to have a return statement after that. Okay, so let's look at another example. In this example, I want to show the usage of the refresh header. Suppose we want to do a countdown page where a clock counts down from 10 to 1, and then there's a rocket launch or something like that. So let's first create the servlet very quickly. I'll call this countdown. And countdown, of course, will have a counter, and this counter will not be shared by any other servlet, so I'm going to do it simply using a instance variable of the servlet. So let's say it starts from 10, and then we'll display something. Let me copy over some display code. And we'll say if count reaches 0, we'll display launch, and otherwise we will display count itself. We'll say and then we'll decrement count, something like this. If we run this, let's see if we can just do it here. Countdown. Okay, now it says 10. The problem with this is that HTTP has a request response model, meaning that a user or a client has to send a request in order to get a response. Response doesn't come to you automatically. If we want to do something, we'll have to ask the user to manually click refresh to send another request, another request, another request. And that's not an ideal situation. Although the request-response model works most of the time, it's not quite suitable for certain application cases. For example, imagine you develop a web application that monitors the stock prices of the stock market. And the stock prices changes all the time, and you want the user to be able to see the most recent stock price. However, you cannot ask your users to sit in front of a computer and hit refresh button all the time. So what can you do? How can we show the user new data when the data on the server has changes without asking the user to manually refresh their browser? There are, in fact, sophisticated mechanisms and solutions to implement something like that. But for us, we can do a quick and dirty version of that simply using the refresh header. Refresh header is a way for the server to tell the browser, please automatically refresh after a certain number of seconds. So instead of asking the user to manually refresh the browser will automatically refresh itself. The way to do it is, in fact, quite simple. So we'll say not only we print out the count, but we also say response set header, and we'll set a refresh header, and we'll say the value is 1, so the browser will automatically refresh after 1 second. And let's wait until it's restarted, and let's go back to that page. Where is that page? So now you can see the values automatically changes. I'm not clicking refresh button myself, and once the count reaches 0, it says launch. So this is a simple example of showing how to use a certain response header and how that affects web application. Refresh header is kind of a nice little header that has certain usage in certain situations. But more importantly for us, this shows how we can use set a response header. And with that, let's do a more complex example that involves a couple of more headers, but also some file I/O operations. So let's say I have an image file and I want to get that image file from the server. So far, we've been dealing with servlets generating HTML pages. But what if a servlet has to send back an image in an HTTP response? So let's first get an image. The image I usually use is this one. So we go to Google search and search image search and search for CS3220, and this is the image that I use every time. And now let's change this to 3220 so it's easy to code. Now I have an image here on my computer, and let's say I want to write a servlet to download this page. Now the first thing we can try is actually just put this page or put this image inside the project. Let's say I put it inside here under web content, and then we can simply say 3220.jpg, and we get the image. So the first question is actually, why do you want to write a servlet to download this image when you can simply put this image inside the project and let the application server to serve this image? Notice that we're not writing any code for this. The application server itself automatically serves this image. So if you have an image, for example, an icon image or background image that you include in your HTML pages, then this is how you do it. That's perfectly fine. However, imagine that you are developing an online album application, for example, Instagram or Facebook images, pictures. You cannot just put the user's images all in a public folder like this where everybody can see, because you'll lose control and there will be privacy issues and all that. So instead, you would want to put the user uploaded pictures in a folder that cannot be directly accessed, and then you want to use some code to control who can access those pictures and who cannot. And that's why for certain pictures or images, you do not want to put them in a place where anybody can access. So for example, in my case, I actually want to keep the image here in the downloads folder, and then I want to write a servlet that can serve this image. And later on, if necessary, we can add additional code to do access control and so on. And that's the benefit of serving an image using a servlet instead of using application server itself. Okay, so let's write that servlet. So we are going to create a servlet, and I'm going to call that servlet download. So in this servlet, we need to read a file from disk and then write a file to response. So those are the two basic things we want to do. For the first part, we need to use some Java I/O classes. Not sure if you still remember them, but if you check out the API, the class we are going to use to read a file is going to be called file input stream. If you look at the Java file I/O package, you can see a bunch of classes in there. Again, notice that most of them are either called reader, writer, or input stream, output stream. Reader, writer, of course, deal with text data. Input stream, output stream deal with binary data. And so here we are going to use file input stream. Another related class is the file class. And this class lets you to get lots of information about a file on disk, for example, whether it exists, whether you can read or write to it, the length of the file. If you want, you can use this class to delete the file, rename the file, and so on and so forth. So let's first create a file that represents the file on disk. So we'll say creating a file object, and the path of this, if I'm not mistaken, is C drive users and the username, and then downloads, and then we have the name of the file, csv20.jpg. So now we have a file object, and then we need to have a file input stream to read that file. So we'll say file input stream, and the file input stream, this file. And what's our output? Well, our output, remember, is response get output stream. So it returns a reference to a servlet output stream. So let's do servlet output stream. Out is response get output stream. Okay, so now we have our input and we have our output, and we need to write the input to the output. The way to do it is a pretty standard way. Again, not sure you have done this before, but the code looks like this, where we'll have a byte array, and this will be our buffer, and typically you want to create a byte array of a few kilobytes. Right now I'm creating a byte array of 2K bytes. And then we'll need to read from the input. We'll say bytes read, and this will be a counting how many bytes actually read from the file, and we'll say bytes read is in read into buffer, and if it's greater than 0, we know that it hasn't reached the end of the file yet, and in that case we'll need to write it to the output, and the one we use is this one, byte array, and then offset, and then length. So the buffer is this, we always write from the first byte, and the length to write out is the bytes read from the input. And this while loop should continue until we reach the end of the file, and in that case we can then close the input stream. So you may or may not familiar with this code, but it's pretty boilerplate binary input-output code. So if you are not too familiar with this, that's okay. Just remember how it's usually done. So now we have that code, we can actually run this and see what it looks like. What does it say? Oh, let's save it and let's run it. So as you can see, it actually works, and this in fact is the first HTTP response we generated without the first non-HTML response we generated. So far, all the other responses we generated are HTML pages, but this one is in fact an image file. And just to make sure we are actually downloading this file, if I change this to something else, and if we refresh, we get a file not found error. So that shows that we are indeed getting this file, not something else. So if you look at this code, we generated a binary response, but we didn't actually use any header. So the first thing we should have done is we should have said response set content type, and this should be image JPEG, since it's a JPEG image. And then there are a couple of additional content response headers we could have set. Notice that if I try to save this picture, it will save this picture as download.jpg because the browser doesn't know that this file or this image should be called cs3220.jpg. It only knows that this is a JPEG file and the URL is download, so if you try to save it, it will try to save it as download.jpg. So how can we tell the browser what the file name should be? And this can be done using the content disposition header. So we can do something like this. We can say response set header, and then we set a content disposition header, and this header has two parts. In fact, the first part tells the browser whether to display the file or pop up a download window to download it. Inline means just display it in the browser window. And the second part is file name, and we can say is cs3220.jpg. Not set date header, just set header. Now, if I refresh and right-click and then say picture, so notice that now it gets a cs3220.jpg name from that content disposition header. If I change this to attachment, wait until it restarts, or yes. And if we refresh this again, notice that it automatically pops up a save file dialog. And so instead of trying to display the file directly inside the browser, it will ask the user to save it. Again, it gets a file name from the content disposition header. And one more thing we could do is we can set a content length header. And we can get the length of the file. The content length set header requires the header value to be a string, and this one is a number, so we can just change it to a string by concatenate it with an empty string. Setting content length for a file response is often useful if you download a large file online. For example, oftentimes you can see the browser shows how the percentage of the file that has downloaded and how much needs to be downloaded and how long it will take and so on. And the browser can do that because the browser knows the length of the file from the content length header. And if you do not set content length header, the browser won't be able to show the download progress. But if you do, the browser will show the download progress to the user. So how to do Java file I/O, content setting content type, generate binary response, and setting a couple of additional headers. So that's the download example, and here's a quick summary of what we have covered in this video. HTTP response consists of a status line, some headers, and a response body. It's important that you know status code ranges and some common status codes like 200 and 404. And In a servlet, we can set various response headers when necessary, and when we want to generate a text response like a HTML page, we use response writer, and when we want to generate binary response like an image file, we use output stream. So this is it for this video. See you in the next one.